Today, I'm going to go over the exam. For some of you, that may be redundant, and for some of you, hopefully, it'll be somewhat informative. By and large, the class did well. There are a few areas that I want to make sure are understood because it seemed that there was a little confusion in a couple of areas. So I'm going to start by going over the exam. We'll see how long that takes, and then uh, then just to try to get it for the record a little bit more, I'm going to circle back, and talk about this compare to and comparator um, thing that was not being able to record it last week, and then after this, we're gonna talk about maps and strings and input output. Uh, we've dealt a little bit with output with the print line statements, but uh, we're going to start interacting with the file system a little bit more. Okay, so the the exam. It starts from the top. Um, Again, it was a bit of a challenge, and I'm a lot of the things that were kind of missed here would have been picked up with NetBeans, because NetBeans would have gently reminded you about what was going on. However, um, the the thing is that it's important, even if you're using something like NetBeans, which is a very powerful tool because it gives you a lot of valuable feedback. It's not the be all and end all. It's really important to understand how things should be working to, well, first of all, understand when you get an error message, why there's an error message, but perhaps more importantly, to kind of have a model in your mind of how the code is going to work before you even run it. I mean, in a sense, it's valuable to be kind of running the program in your head before you run it on the computer, because if they match, then there's a good chance that everything is copacetic. If they don't match, then either there's a misunderstanding on your part, uh, or maybe it hasn't been entered exactly correctly. So one important thing that was talked about has to do with visibility of things, in particular variables. So the first question, we have a kind of a weird class here, but it has two static variables, 1 and 2, and it has two instance variables, current value and number changes. Now, the first question was, of the variables, the new current value is an instance variable, an instance method. The method new current value is an instance method. And so instance methods have direct access to all of the variables in the class, both instance variables and static variables. In particular, both 1, 2, current value, and number of changes are directly visible to the new current value instance method. That's because as an instance method, it can see both instance variables and static variables. However, the cold reset method is a static method. And static methods do not have access to instance variables. And if you think about it, there's a reason for that. A static variable has no context, no object instance context. So a static variable only has access to the static, a static method has only access to static variables, not instance variables. So a number of answers said that the cold reset method had direct access to the instance variables, and that was incorrect. It does not. It only has access to the static variables. Okay, the new current value, that I think most people sort of got that. The idea is that you set the current value to the new value, and then number of changes was incremented by 1. So again, I think a lot of people got that. If you didn't, just sort of double check the solutions. And then the two-string method, again, most of you wrote a reasonable two-string method that had both of the values. Why is it useful to have these two-string method? It's important to understand, and that kind of comes up a little later, is that when you do something, when you have a reference to an object and you do like a print line object, or whenever you use an object reference in the context where it would have been a string, then what the virtual machine does is it invokes the two-string method of that. So if we're trying to figure out what is going on with an object, it's always useful to have this two-string. And we've been doing that pretty much since day one with the single cards. The single card, what is it you want to know about it? I want to know its suit and its value. And so its two-string method would return that information. Okay, so but make sure that you, in particular, understand which methods have access to which variables. That's important. Okay, so now, number 2 was, this was just a similar question as to remember the swap one, where you call the swap and it swapped to 2 values, but in the calling method, it didn't change them. The same thing is going on here. When this says sort of multiply, this gives the impression that if I give you an A, a B, and an X, then it will set the value of X to the product of the 2. So the name of the method suggests that. The way it's structured suggests that. You look at the code and that suggests that, but that's not what happens. What happens is, before the multiply, of course you have the 3 values. So A would be 1.5, B would be 2.0, and X would be 1. And then you call multiply. So when you're in multiply, of course, the value of X is the product of the 2, which is 3. But the scope of this X here, this argument X, the scope of that is simply that one call to the multiply method. And so when you return from it here, when you return from it, the value of X here in the main method has not been modified. The value of X in the calling method does not get modified, for at least for primitives. This is true for objects as well. The object itself is, even if something happens inside the method, does not get changed. The only thing that can happen to an object is that if you invoke a method on it that changes one of its instance variables, then that will indeed change the value of the instance variable. But the reference to the object does not. But in particular, especially for primitives, for a primitive value, when you call the primitive value and pass it an argument, when it returns, that whatever happened to it inside just goes away. It's important to understand that. Okay, so this was kind of a little bit of a constructor maze, and the idea here, and again, we talked about overloading methods, and in particular overloading constructors. So what this question puts together is, first of all, overloaded constructors, and then second, what happens with a call to either super or this. Now, as you can see, there are 3 constructors, this constructor does not have a call to super, but Java will put one in for it. So it's important to understand that. But this constructor and this constructor both have calls to this. And so this in a constructor well, first of all, has to be the first call. And second, it will call another constructor. Okay, so here's the other class, the main class. Okay, so we have a value of 3. We instantiate the class with that value. So let's trace through what happens here. So I'm calling it with an int. So remember, with an overloaded method, the only thing that, and in the case of an overloaded constructor, the only difference is the signature of the arguments. In other words, I have one with an empty argument, I have one with a string, and I have one with an int. And so how does the virtual machine know which one to invoke? Well, here I'm invoking the constructor with an int. And so that's going to go to this constructor here, the one with an int. Okay, so let's trace through what happens. The first thing it does is it calls this with an argument of a string. And what that will do is that will immediately invoke this constructor that has an argument of a string. And what does this immediately do? This immediately calls this with no arguments, which invokes this constructor. And what this constructor does is now notice that this is an instance variable message. This sets the instance variable message to a test, period, with a space. Okay, so that happens. Then it returns from that, and then appends to the message the word this with another space, and then it appends to the message the argument that was passed in. The argument that was passed in is the string the is. So at this point, the message is a test period, this is. Okay, so and then at that point you return from that. So at that point nothing gets printed, but at this point the value of the message instance variable is a test period, this is. And now when it's printed, what does it do? It goes to the toString, and so it gives you this message, and then prints the value. So where do we get the value? Well, the value we got right back at the very beginning when we called the first constructor. It set the value equal to the value of the argument that we passed, which was 3. So what would happen is you would say it would print out a test period space, this space is, and then another space, and then 3. So that the key here, okay, what this question put together was a number of things. One is what's happening with instance variables. Unlike the previous question, the scope of an instance variable is the entire class. So anytime you do something to it, it happened. It just happens, and whatever you do to it is going to persist until you do something else to it. So in particular, because the scope of message was all of these constructors and including the toString, there was not the passing out of scope issue that we had in the previous question. Okay, so that's the difference between local variables and arguments versus instance variables which persist. Instance variables persist in the object. Local variables go away after you return from the method. Okay, now this actually pretty much this was I know kind of a wordy question, Um, pretty much everybody more or less got it. The we're going to be kind of well, not so much playing this, but we're going to use the sort of the movie things to kind of read a file that has information about various movies, and then sort of manipulate that and sort of see what various things are going to be done. Again, uh, obviously, if if you're writing an application that will say take a movie format like an MP4 or something and actually play it and so that you see it, that's a little bit beyond uh, beyond where we are right now. So, um, nevertheless, what this was about was sort of taking uh, taking what's in the UML diagram and turning that into code. And you all pretty much did a good job with that. So that I was happy about that. Okay, so now here, and again, this was one where it's like if I'd let you type it into NetBeans, then it would have you would have kind of seen the answer. Um, the key here is integer arithmetic and also promoting things to double. So here's the thing, is that the way that you evaluate an expression, okay, this actually had several concepts in there. The first concept actually is integer division. So integer arithmetic in a strongly typed language is different than in a non-typed language like JavaScript that you may be used to. So this was um, some of the things that you've used in JavaScript kind of interfere with understanding what's going on here. What's going on is that sum is 102, count is 52. That's going to be slightly less than 1, and so it's going to get truncated to the integer 1. So what happens, and this comes in where and this is true in JavaScript as well, when you have an assignment statement, what happens is you evaluate the right-hand side and then try to assign it to what's on the left-hand side. So what's on the right-hand side is an expression, and what's on the left-hand side is a variable. So, but the thing, so to evaluate this expression is integer division, which is 102 over 52, which is the integer 1, not 1 point whatever, but 1. Now, taking it, and then in Java, you're allowed to assign an integer to a double. So there was a little confusion about that. And actually, in my opinion, you shouldn't be allowed this should be an error because it's a mismatch, because in a strongly typed language like Java, an integer and a double are two entirely different things. Nevertheless, kind of just going back to the days of C and whatever, they let you do it. Okay, so this evaluates to 1 because it truncates and then assigns that 1 to a double value. So when it prints it out, it's going to be 1.0. If you just said 1, I think I let that by, but you know, but that's not going to be an error. Okay, this is now here again. What this one was kind of touching on is the fact that the scope of this variable x is entirely within this for loop, and so what you get is you get a compile error. So here you would get a red squiggly. Not here, Word is giving you red squigglies because these aren't, you know, it says these aren't words or something. But NetBeans would give you a red squiggly here because it would say, you know, variable x is not known. So this is a compile error. It's not a runtime error because the Java compiler would not even let you run because x is out of scope. So again, understanding that the scope of a variable within a for loop, when it's defined like this, is just within that for loop and no place else. Okay, this was, and again, this is, this question is an example of really when you're debugging a program and trying to figure out what is going on with it. Again, you want to be able to kind of run the program in your head to understand what's happening. Okay, so what's going on here is that, okay, start is 5, count is 0. Now remember, the do while is you execute the block and then keep testing it. So you begin by decrementing start and then printing out count and start. So count is 0, start is 4 at this point. Then count gets incremented by 1 and you do the test. Start is 4. Is 4 bigger than 2? Yes. So you would, like if I'm printing, so you would have count would be 1 and 4 would be, I'm sorry, yeah, no, count would be 0 and 4. That would be the first one. Then because the test passed, you go back, start is now 3 and count is 1. 3 is bigger than 2. And so now you would have 2 and start is now 2. And now when you do the test, it fails because 2 is not bigger than 2. And then finally you would print, oops, where'd you go? Finally you would print the 2 there. So that, you know, so this is the output that you would expect to get. And the thing is that when you're writing these loops and you're expecting to see what happens, especially the while versus the do while can be a little tricky. And so it's important to kind of test your code like this by working through it by hand and seeing what you expect to get. And then if you get something different than what you expect, kind of go back and see what it's almost always you're not, there's something about it that you're missing. Okay, so I mean, so the thing about writing code is it's not just sort of the writing of the code. What you're doing is you're creating chunks of logic, and those chunks of logic are, you know, it's these computers are just so stupid because they do exactly what you tell them to and not what you want them to. Okay, so I think I only got one comment about this. What I was, the numbering was, you know, it said 6 of 1 of 9, 6 of, you know, 6 of 9, and then if you don't watch Star Trek like I do, you know, this was a character called 7 of 9. So that was, I think only 1 or 2 of you are Trekkies, so you noticed that. Anyway, okay, so actually everybody got this. The key here was simply to understand that, first of all, a tree set was going to keep them in sorted order. And then second, because it was a set, okay, we knew that these, we had a list of integers, and that list contained some duplicates. In particular, I think there were several 2s, and a couple of 27s. And so the key here is to print them out in sorted order with no duplicates. And you all got that. So that was good. Okay, this one was a little bit concerning to me. So I want to kind of emphasize this. Okay, we had an abstract class, and this class called base class had to be declared abstract because there was one abstract method. Everything else was a concrete method, so we don't have to worry about it unless we somehow want to override it, but that wasn't necessary. I mean, and in fact, not very useful. Okay, so to have a concrete subclass, the one requirement was that you have a concrete implementation of this abstract method. So if you do not, then you can subclass this without implementing the abstract method. But if you do, you will have to declare it to be abstract. And what was asked for was a concrete subclass. So you had to implement this. Now, how you implemented it was not, if you just wrote it and it was empty, that was fine, because that would be a concrete subclass. I mean, obviously, the suggestion would be that you would increment the value by the amount, but again, that was not part of the requirement. But you did have to actually implement this. The second thing had to do with the constructor. Okay, now a number of you in your subclass rewrote these instance variables, and that's legal. You can do that, but you should not. The whole purpose here of subclassing this is that we have this variable name and we have this value. We have setters and getters for them. We have a getter for the name, we have a setter and a getter for the value. So so when you subclass, you do not overwrite these values. Or, I mean, you don't redefine them. Again, it's legal to do so, but what that does is that blows away everything that's in the superclass, because everything that you're doing is in the subclass. But what the one thing that you do have to do, in addition to that, is you must write a constructor that calls this constructor with a string and a value. Now, the most natural thing to do is to define, something like, okay, so public class subclass, okay? And I noticed that, yeah, one annoying thing was, okay, so the most obvious thing to do is this. In other words, when you do this, you are, well, this is required because the constructor in the superclass requires a name and a value. If you don't do that, you're going to get this mismatch constructor business. Now, the thing about incrementing the value, how would you increment the value? Well, and again, some of you got this right, okay, but okay, now you cannot what you can't do okay, this is what's suggested by this. And if this were written in the superclass, that's what you would write. The problem is you can't do that. You can't do that. Because why? Because you do not have direct access to this. So the way you would have to do it is you could say set value like this. This has to Okay, so why, and notice that I'm referring to them as this. You actually don't need, you strictly don't need the this, but remember that the subclass always gets everything that's in the superclass. So this get value would actually be would work. Super.get value would also work. The thing is that if you redefine these values in your subclass and kind of work with them here, you're not honoring the intent of this. These values in the base class will not be affected at all if you do that. And what would be confusing, again, if you kind of redefine all of that, well, if you don't override these guys, then when you go to get the name, it's well, a lot. It's going to be something different than what you think. And if you try to get the value or set the value, again, you're going to be referring to different variables entirely. So this is kind of what I was after. Okay, and if there are any specific questions about the way your exam in particular was graded, contact me. I'd be happy to go over it with you and discuss it, and you know, and sort of see if again I am happy to do that.
Arnie,
Again, yeah, question?
are you going to send out our graded exams? I didn't see it on there unless I missed it.
I'm sorry, can you say that again?
Are you going to post our graded exams? I didn't see mine up there unless in case you missed it.
I'm not sure. I mean, I thought that they,
I don't see it visible in the test and exam tab, but it's in the gradebook tab.
yeah. Some Sakai is sort of weird that way.
Yeah, it's graded there, but there's no feedback. Unless I'm missing it.
There should, again, this is the first time I've done this with the Sakai exam. What I did was I actually, I put marks in each of your uploaded files, and then I attach those. So you should be able to see those.
Maybe the feedback hasn't been made available because there's no feedback option on the midterm, at least on this side.
All right. Well, there was a place for comments, and I only made a few comments, but again, I added attachments, and I can see the attachments, but are you saying you can't?
No, we can't see it. So like our quizzes, you can click on the quiz and it'll give you, it shows that there's feedback, but there's nothing like that for the midterm.
Okay, well, all right, I'll see if I can figure out what's going on with that.
Okay, it also like if you go into the test and quiz section, the individual score is not there for midterm. I don't know if that has anything to do with it or what.
Well,
actually, it's not there for all the quizzes, so that's probably not it.
Well, I mean, the page I'm looking at, and it shows everybody's final score, and it shows that I've added the attachments. So it's sort of a weird Sakai thing. I'll try to figure it out and see what I can do about it. As far as I know, again, each of you have I guess if that doesn't work, I'll just have to email them to you. So I mean, you can't see your scores at all, or?
The scores are in the grade book. and
Okay.
that's
But that's all you can see. You don't see your attachments?
it. Yeah, no attachments.
Huh. Does anybody know how that works? Uh, things. And feedback, okay. Wait, here we go. Well, it's not letting me change it. Okay, well, I'll have to email each of them to you individually. Oh, sorry about that. I thought it was working. Okay. Okay, so again, just to try to get it down, I want to okay, talk a little bit about these sorted sets. And there's one implementation we'll use, which is a tree set. And again, just understand that sorted set is a sub interface of set. Set is another interface. List is the other main interface we've been using. And the way that sorted set, the tree set, sorts things is in one of two ways. It either uses a class, instances of a class that implements the comparable interface, or if either the class does not implement the comparable interface, or if a different rule for sorting, for comparing two of the objects is desired, then a different comparator can be passed to the tree set to use that. And what we've seen, where is NetBeans? Okay. Is in this example here, numbers are comparable in the obvious way. So integers in particular have, in fact, we can see that by even looking at the source. We see that integer implements comparable integer. And you notice it has a compare to method that says, okay, return compare, the other, they get sort of tricky, but basically it's just the difference of the two. So the default way of sorting integers is lowest to highest. So if that's not the case, so if we just have a hash set, then they're in, just an order which cannot be predetermined. So in this, we're putting 30 numbers into the hash set. the unsorted numbers, and so we can see what that is. And then we can add them to the sorted numbers and then look at the difference. So when we run that, we see here a bunch of sorted numbers, unsorted numbers here at first. And then here they get sorted. So they go low to high. For strings, strings are sorted, you know, the first cut is you think, well, strings ought to be sorted alphabetically. That would be the most natural. And that's almost true. In fact, strings are sorted according to lexicographic order, which means that capital letters come before lowercase letters. So in this particular instance, we have 5 names, or actually we put 6 names in. But what happens is because 1, 2, 3, 4, because Chico, this Chico is lowercase and this Chico is uppercase, they are actually different. So, and then furthermore, since we are sorting them, it goes, you know, C, G, G, C, GR, GU, H, Z, and then lowercase. Now, what if, all right, so let's, what if we wanted to sort the numbers, not lowest to highest, but highest to lowest? Well, one of the things we can do, actually Java provides some ways to do that under the hood, but just to understand how these comparators work, you'd write a new comparator. Let's call it reverse integer comparator. And to implement the comparator, we write it this way. And we use the generic thing with the angle brackets that we've seen. Now we get a red squiggly. Okay, so cannot find the symbol. What's the thing to do when you can't find the symbol? You fix the imports. And 9 times out of 10, that'll fix it. You say, well, oh, it didn't fix it, but it did, because we now have a different error message. Now, you may have noticed, and I hope you understand this, is that sometimes you'll get an error message and then you try to fix it and you get another error message. The thing to understand is that's progress. It means that if you have a new error message, it means you've whacked the first mole, but there's another mole that pops up. So what is it? Again, understand them. The messages are often very informative. It says reverse comparator is not abstract and does not override abstract method compare. Okay, again, what is it? If you're implementing an interface and you do not implement all of the methods in that interface, then you must declare it abstract. So I mean, I could make the red squiggly go away by declaring it to be abstract. But of course, that's not very useful because it doesn't really do anything. So instead, NetBeans has a very useful little tool here, again, which gives me some options. So I could the top 2 are the 2 main ones. One is I can make it abstract, or I could implement all abstract methods. And then this lists a whole bunch of things, but really it's the compare that we want. All right, and this is actually a very useful thing. So what it does is it throws an unsupported operation exception. And what that means is that if we try to use this, it's always gonna get an exception, and that forces us to actually do something about it. Now, their default names are not, I don't particularly like. Let's call this the first. I'm gonna change that to the first and the second, just because 01 and 02 are just, Okay, so now what do we need to do here? There are a couple ways to do this, and I think in the sample exam, I think I gave some. So again, we want to reverse things. So instead of returning the first, here I'm using the compare to method. And I'm saying, okay, instead of comparing the first to the second, if I compare the second to the first, now when I go back to, let's go back to my sorted set example. So here are my sorted numbers. Okay, so now here's what I do, is I want to give it an instance of this reverse integer comparator. So when I instantiate a tree set and pass in an instance of a comparator, that says that the tree set will use this comparator rather than the one that's default, or the one that's just you know, if I'm trying to put objects in that do not implement comparable, then I can't even put them in to begin with. Now, over here, just to kind of illustrate the hard way of doing it, I iterated through my unsorted numbers and just sort of added them one at a time. Now there's a shortcut to that. I can just add them all in one fell swoop. It's called add all. I'm just going to add the unsorted numbers. So, and this is true for any collection, that lists, sets, what have you. They all have the method add all, because that is specified in one of the interfaces, the collections interface, I believe. So what that means is that any class which implements, among other things, the collections interface is going to be able to, must implement this add all. So when I print these out, now what I'm expecting to see is, okay, so here's the ones with increasing order. Here are the ones with decreasing order. Okay, so what happened? Well, because this tree set used my reverse comparator when it was comparing two numbers, instead of saying, okay, here the lower one goes first and the higher one goes second, here this was saying, now the higher one goes first and the lower one goes second. Why? Because I was reversing. Now, as pointed out, there are other ways of doing this. I can say minus first compared to second. That works just as well. So you see, I get exactly the same thing. Or another way is I could actually simply take the first, the second, and subtract it from the first. And that should give me, again, the same thing. You notice the numbers are changing because because every time, if you instantiate random this way, it just it uses the system clock to initialize it. Next quarter, we're going to delve a little more deeply into what goes on with these pseudo-random numbers. But okay, so here we've seen 3 different ways of implementing a particular comparator. And if you remember last time, we said, okay, here we have these single cards. And let's see, where is it? Here we had the test. So, and actually, just to show you. Um, Okay, so this will let us do that, but let's add a new single card. Okay, let's try to do this. You see, what would happen? Well, what happened if we don't do this? You remember we defined our comparator for our sorted for our single card, and we passed that to the tree set here. Now, what would happen if we didn't do that? If we just tried to put a single card on? Okay, notice no red squiggly. So the compiler says, okay, you're the boss. When you try to put this guy on, I assume you know what you're doing. And there's no reason that there's no obvious reason for that to fail because you've defined this to contain single cards. You're putting a single card in. That's fine. See, if I were to try to put a number in, oops, oh, not here. If I were to try to put a number in, say 3, I do get a red squiggly. Why? Because incompatible types. Because as you know, you said you're going to put single cards in. You're putting an int in. That's no good. All right, but here I'm going to get a runtime exception because there is no because the single card does not implement comparable. Say cannot be cast to a comparable. Blah 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 blah. See, I get an error here. So this is all, oops. This, come on, what are you doing? This cannot, you can't do this. But what you can do is that. Okay, and I see we're out of time.